Take it away.
Thanks, everyone. First, the mandatory bio slide. I work as a CTO as a service person, which means that I advise and coach several tech companies on software development, IT security, IT architecture, those kind of things. I'm also an amateur radio licensee. I love radio stuff, which you will notice here. I'm a board member of the OS Gothenburg chapter. Some open source contributions, and I have programmed 2 satellites, and I love listening to them. So enough about me. How about you? And specifically to this presentations. How many, could you please raise a hand if you heard about LoRaWAN? All right, I would guess maybe 40% or something. And how many have heard of the Helium blockchain? Oh, much fewer, I would say maybe 10%, and I'm not sure if there's much overlap. What I've found is that a lot of people work with the Helium blockchain, but they don't know what it actually does, which to me is quite interesting. But all ways that we can get new people into technology is good, even if it's through crypto. So for those about 60% who haven't heard about LoRaWAN, it's an IoT network, and compared to the normal cellular networks that we use every day with our phones, it's much more low power. My phone lasts maybe throughout the day if I'm lucky. Those devices are maybe a little bit larger than a phone, but not much, and they can have between 5 and 10 years battery life. So it's a big difference. And if you want, for example, put a GPS tracker on one of those big containers that go on the ships, you don't want to go out and charge them every day or even every year. It's not possible. And the network uses gateways, which has a similar role to base stations in a cell network. So most people have seen those on roofs and things with normal cellular, and they are similar, and I'll show you. I have 2 with me. It's also more low cost in terms of hardware. A phone, well, you can buy an Android phone pretty cheaply today, but these devices cost from maybe 35 euros in single quantity, and if you buy 100,000 of them, of course, you will get a discount. And the subscriptions are about €0.50 per month, sometimes lower. So much cheaper to use this kind of network than to use the cellular networks. And one reason that it can be cheaper is that it's much longer range, so you can get the same kind of coverage with fewer gateways. Building a new communications network, even if it's so cool as LoRaWAN, it takes a lot of money. And the problem is that nobody's going to spend a lot of money putting out all these gateways before there's subscription revenue. And of course, no one in their right mind would buy a subscription to a network that doesn't have coverage yet. So the problem is illustrated by this curve that it takes a lot of money until it lifts off. And that's where the Helium blockchain comes in. What the Helium blockchain does is that, yeah, we know there's not much traffic yet, so we will pay people in our own cryptocurrency for just providing coverage. So a gateway will send out a ping. All the other gateways that hear that ping, they register that. And by that, you know that in this geographical area, you have coverage. Because we could hear from here to here, then a device being somewhere here will probably work. And all gateway owners share the distribution of coins. This incentivizes people to buy the hardware because they are not that expensive, but a bit. And it incentivizes people to find good locations. The higher up, the more you can get others to see your, and it's also better for coverage. So does this really work? I mean, does any blockchain really work? This is what happened the first 18 months. So we have from the summer of 2019 to January 1st, 2021, so 1.5 years ago. What did they reach? About 16,000 base stations or gateways globally. Not really that impressive. But then something happens. So this curve shows the last 3 years. And the curve, so the curve I just showed you is half this until about here. And now there are more than 800,000 gateways in the world. And it's all been paid for by other people than the Helium company. So that's pretty impressive. And the global coverage map today looks something like this, which is also from building from scratch 3 years to have a global coverage like this. It's never been done before. And let's see if I can get this running. So this is Stockholm, I think. I have a little trouble seeing from here. So this is how the network has grown the last year or so. Then we have Berlin. And for being a crowd-sourced network, I think this is super cool. Here we have London. But it's not only in the large cities. It's also in USA. That's where it started. So we have New York, and we can see Manhattan was covered pretty quickly. But also outside the city, we have a lot of coverage. The Helium blockchain is currently about number 50. It goes a bit up and down every minute. And the latest market cap was around 1 billion. Before the most recent crypto crash, it was about $3 billion. So there's quite a lot of value created for some sort of definition of value. So enough with the background. The Helium gateways or base stations, they can look like this. This is an indoor variant. Of course, it has a lid, but it doesn't look as cool with the lid. So I just removed it. So you put this costs roughly about 500 euros. And then we have the outdoor version with a beefier antenna. And the inside looks pretty nice as well. And since these generate the blockchain value based on coverage, they don't do a lot of computation. There's a Raspberry Pi compute module in it, and then there's some other things. So the total consumption is about 5 to 15 watts, so 1 to 3 times a normal Raspberry Pi. And until just 3 weeks ago, all these were full blockchain nodes, but they realized that doesn't really scale. So now the blockchain has grown, so it's no longer on these nodes. But every gateway is registered in the blockchain. And to be able to manufacture one of those, you need to follow quite stringent requirements when it comes to security. And this is where the fun starts. I've highlighted a part, so this is cut directly from GitHub, where they describe these are the requirements. So they say it needs to be reasonably secure and resistant for tampering. That's a challenge. I accept it. So I started just using Nmap to see what's going on here. And I noticed we have port 80, port 22.22.2. The other ports I know are used for the blockchain network, so I wasn't that interested. But the first two, all right. And the one with all twos, my guess was something with SSH. So I just tried to log into it, and it said denied. So then I knew we have a SSH server, and it seems to only support public key authentication, so no password. Okay, it would have been really nice if it did, and I could log in, but it doesn't seem to. And I checked the version. So it's a fairly recent OpenSSH, and I checked the National Vulnerability Database. It shows some vulnerabilities, but nothing very easy. So I decided to put SSH on hold. On port 80, I used a tool called Crawlbox. There are lots of tools like this that can just try commonly used URLs or endpoints, and it found something on an address called scheduler. That could be interesting. I just accessed that endpoint, and it had some info, allowed hosts anything, and it's running. Sounds promising. So what is this service? I just Googled what I found, and it seems to have something to do with something called Flask AP Scheduler. So Flask is a web framework for Python, and AP Scheduler is advanced Python scheduler. Okay, schedulers usually run things, and I want to run things. And the Flask AP Scheduler has an API. That's convenient. And it seems that we can do a lot of fun stuff. So I just checked what jobs there were. We have a job called ship diagnostics. All right, kind of makes sense. And this vendor has quite a lot of the software in these are on GitHub. It's open source. So I checked their repo and found that, yeah, there is a task or a Python function that is called run ship diagnostics task. So we can call Python functions. It's a start. And I tried calling os.name because I want to do things with the OS. The Python world isn't that fun. And I got an error back saying POSIX is not a callable object. Well, POSIX is what OS name normally returns. So we have some sort of evaluation going on here. And I'm not sure what I did. It was probably very late at night, but I figured out that normally in Python you call os.name, but here I needed to call os:\name. And if someone knows why, please let me know later. I have no idea, but this notation works. I could evaluate the environment and get all the environment variables. And we're running at root, it seems. Very convenient. But still, running this, I didn't get that much information. So I installed the AP scheduler locally on my machine, and accessed it. So then I could see what happened on the other side. So I tried something, it said, well, I'm missing arguments. Okay, read up a bit, try to tweak it. And then I figured out how to run the uptime command. So we have some sort of shell. We can run binaries. But this output I got on my debug instance on my local machine. I wouldn't get the output through the curl command. So I piped the output to curl, posted it to just a simple log file that I have so I could read it. Then I tried to install some tools, ran apt-get update. Well, I could do other things, but that's very convenient to just use the package manager. But when I ran it, it says no data on my server. You see here, it also says expect 100 continue. So that's how you in HTTP use several packages to concatenate a long answer. I thought Golang is fun, so I'll just find some code on the internet that does support chunking, so I can get the output. And now I get the full output of the command I ran. I installed Netcat because it makes things easy. And what's really neat with this scheduler is that it will not spawn more shells while the existing shell is running, because the scheduler is supposed to keep one thing running. But if my reverse shell dies, the scheduler will spawn a new one for me. Very nice. So now I have a full reverse shell, and I'm thinking about that SSH service that I saw earlier. But there's no SSH process running, and there's nothing that binds to port 22222. I knew then that these devices run on something called Balena, which is based on Docker. So I'm probably inside a Docker. That's no fun. So we need to escape out of the Docker. And I figured out that I could... There are lots of really fancy Docker escapes out there, but I could read the entire SD card that has... Or it's not an SD card, actually. It's a soldered thing. I can't remove it, but I could mount anything I wanted. So I mounted, I just messed around until I found something interesting. I found an authorized keys file that I just added my own SSH key. Because why make it hard when it can be really easy? So I just SSH into the machine, my key is accepted. I am root, I can list all the Docker containers, I have full access to this machine. Well, that's what I kind of wanted. Well, I didn't really want that because I was responsible for rolling out a few hundred of these. So I didn't want them to be this hackable, really. But okay, I had local access. Nobody's gonna put their miner on an open internet connection, right? Because we have firewalls and we have NAT routers. So I just ran a Google search for some text that appears on the port 80 endpoint. The first, just a slash, it's a diagnostics page. And see, this is page 8. and there are 491 results that are remotely exploitable. I accessed a few of them just to check, and yeah, it's the same stuff. So what can we do with a remote shell? Well, a lot of people that buy those, they do it to earn this coin. They have a crypto wallet. They put this on their home network, where they probably also have the device, probably the phone that holds their private key to the wallet. So I have a foothold inside their home network that I can use to attack people, or at least gather information about them. That's not really good. You could, of course, enlist them in a botnet. There's a really interesting thing because you get rewarded on how many other signals you see. I could then steal the traffic that all these 400 something see, send that to my own miners and claim that I also saw it. And that would give me more crypto. So that's something to do. And during the break, I discussed it briefly, and I got a really great suggestion. The crypto keys are in an HSM, a security module. So I can't really fetch them, even if I'm root. But maybe I can write them. That would mean that I could enlist all those that I found on the internet to, instead of earning money to their owner's wallet, they could earn this crypto to my wallet. I like that idea. Of course, I didn't do that. I did the responsible thing and tried to figure out how to fix this particular problem. And as with a lot of problems, the fix can be pretty simple. Their code had a line that says scheduler API enabled true. If you set that to false, there will be no scheduler endpoint, and there's nothing you can do. Of course, it would be good to tighten up the Docker security, because isolation without really isolation, how clever is that? But coding is hard, and I was thinking, would a code review have caught this? And I checked some commits. Of course, I could do dig in Git and find when it was introduced. And would anyone guess which of these commits introduced the problem? Do we have any hands up for the first one? Right? How about the second? All right, some hands. Third one? Nobody thinks that. Okay. Fourth? Yes, some. All right. And it's actually the second one. This was introduced when they converted the app to a Flask app. And yeah, it's hard to find. But I think that there will be mistakes made. And the important thing is there a way to report the problem? Is there a way to fix the problem, push out a fix? Do you have automatic updates? I contacted the vendor. The first response was like, we don't think this is important. And that was partly me to blame, because I hadn't really explained. I said, I can do this on my miner. And they're like, well, you own it. You can do whatever you like. I was like, yeah, but I can also do it to all these sites or machines I found on Google. And they're like, okay. So luckily, I had some previous contact with this company. I had met the CEO and the two founders in a pub in London half a year earlier, and I had a support access through Slack to them. So I posted in the support channel, it took a while before they really got what the problem was. And when they got it, 5 minutes later, the CEO pops in the support thread. I don't think that normally happens on big companies, but this is quite a small company. And after they really realized what the problem was, it was patched later the same day, I think within 2 hours, and they pushed out an update later that day. So then, at least this particular way of attacking was plugged. So, of course, you're security people, you probably know how to attack things already, but maybe not hardware. Well, hardware runs software. And you can use tools that you're probably already familiar with. I used Nmap to check which ports I could attack, the crawlbot thing to see what endpoints are available. And there's something I was thinking about, because crawlbot has a word list of, I think, 6,000 different endpoints that it tries. Since a lot of the software is open source, I could have pulled all the strings from the source code and just fed it through the crawlbot to see if I found something else. I used curl to access the service. Some people might prefer Postman. Of course, that works as well. You can use whatever tool you like. I had the chunked server. That was a big key to exfiltrate the information from my command, because before I found out that, I could not get back what really happened. So it was a lot of trial and error. And then netcat for a reverse shell, pretty basic. So that's what I did. Any questions?
Does nobody have any questions? I mean, we're talking about crypto here, guys.
Yeah, if someone has the bullshit bingo scorecard, I think I'm pretty good at it now.
Did you mention cyber yet?
No.
Well, I did.
Yeah, thanks.
Nothing? Well, actually, I have a question. So you mentioned you found, what was it, 450 something open instances of this?
Yes.
But the coverage map is huge. What did you say, like 800,000 devices?
Yeah, there are multiple vendors.
Right.
So there are like 10 different vendors. This particular vendor, I think, has shipped about 80,000 or something like that. So 10% of the network.
So would you think that the reason for there only being 450 is that those were only the ones you found, or is it that people are they're not remotely accessible, or have people been making their own configuration changes? What do you think?
I don't think they made configuration changes, because this is supposed to be fairly locked down. Without getting this access, the vendors are not allowed to give shell access even to the owner.
Right.
So I don't think it's remote configuration. It's probably maybe people put them on somewhere high up, and there's not an internet connection, so they use a SIM card that's not behind a NAT, so it's full access. That could be the case. I tried searching a bit through Shodan, but I didn't find anything interesting, because there it would be interesting to get the statistics to see what types of IPs, what countries, but I didn't dig into that.
Okay, well maybe it's yeah, exactly. And maybe it's an area for further research.
Yeah, it could be.
Okay, do we have any more questions? Okay, it looks like that's it. Oh, actually, over here. Could you repeat the question, Michael?
If I estimated the value of tokens I could steal, existing tokens, then I would have to break into someone's wallet. And then, of course, that wallet could be either empty or have a few $100,000 or euros. The average for any of those on the network is about, I think, about 100 euros per month right now. So with these 450, it's 45,000 euros per month. That's a pretty nice passive income.
Yeah. Yeah. Any more questions? Okay, looks like that's it. All right. Thank you so much.
Thank you.